Hi, my name is David Siegel. This is another business agility video. I was giving a talk the other day to a class of Hans Hugentobler at the Hochschule Lucerne in Switzerland. Most of the students were from Lucerne and Zurich. And I mentioned something that I didn't get to finish, so I thought I would quickly make a video from my big deck on business agility. I have sort of five major approaches to understanding business, and then I have the following categories. And I have a big workshop. It's a full-day workshop on the Agile worldview. I was trying to describe the difference between ordered and unordered, and so I want to use this module from the business agility matrix of learning sessions. And let's just take a look at ordered versus unordered and then go from there. So the question is, what world are we in? I always want to look at a problem by starting with this question so we understand the context for the kinds of problems we're going to be up against. And that involves understanding the difference between ordered and unordered, which a lot of people can probably understand. And then we'll add another axis to that, and that is the distribution of results, the distribution of outcomes from a normal distribution to a power distribution. This power distribution is also called a Pareto distribution. You're probably familiar with. And just to review, the normal distribution would be something like the height of people in the population or the weight of people in the population, possibly the IQ, or a number of other things that go under, that play out or that result in a bell curve of outcomes. But then other things have a power law. For example, how much money people make, the income. One person, one of the top 10 wealthiest people in the United States makes about as much money as a couple 100,000 other people. And so it's a very different kind of distribution of results. And you could think of things like bestsellers, books. Books are in this category, or movies, music, anything that's generally popular, memes, YouTube videos, the top YouTube videos, YouTubers, there's a couple of them, and then everybody else falls into the long tail. And these four quadrants help us understand which world we're in. And of course, there's no bright line between any of these things. If we look at the ordered world, I usually think of the ordered world as let's go down here to the simple stuff is where you are looking at outcomes where you know your expected value. You know that it's under a bell curve, so you can make bets here. It's predictable. It's like the games at a casino. You can predict over time what the mean values would be. And then when it's unordered, there are many things here that still have the normal distribution, but have some surprises. For example, things like maybe the prices of homes, or maybe the change of home prices, because prices of homes is going to be up here. And then we can also realize that the normal distribution is usually independent. So the heights of people are usually somewhat independent of each other, and there aren't a lot of dependencies. And then when there are dependencies, you get these kind of chain reactions. And that's where you can find that, for example, in business, you might have a best practice that works over time, but over time it also evolves because, businesses have a lot of moving parts, right? But you could learn from your experience. And for example, when an airplane crashes and something goes wrong with the airplane, there are a lot of dependencies, but we can learn what went wrong. And in general, that problem never comes up again because there's a good system for communicating what happens when airplanes crash. And all the manufacturers and operators are able to to prevent that from happening again. So this is kind of a statistical look at the world of ordered dependencies. And then unordered dependencies are where we have the butterfly effect, where some tiny thing can have a huge effect later, and where some seemingly insignificant thing can, like a little viral outbreak in one city in China, for example, can, because of the dependencies and because there's no way to predict and it's nonlinear, can have a huge effect on the world. Okay, so let's just explore this a little bit more. Again, we get back to the distributions and the power law here, power distributions, and this here is in the normal world is odds. At the casino you can calculate your odds exactly. At the roulette table, you know exactly what the odds are. That's why I say odds rather than probabilities, because with odds and with probabilities you're guessing, right? So probabilities, for example, would be prices of homes, prices of almost anything. You have a pretty good idea and they behave relatively well, but there are some surprises, and you don't know the odds exactly, but you can model them. So this is the world of models that generally work. Okay, and then we have the power law distributions, where in the ordered world it's the known unknowns. And that is, what part of an airplane might break next and cause the next failure. But when it happens, it isn't going to happen again. So we have some degree of repeatability over here, where if we understand how to fix it, or we understand how to manage something, or we understand how to price something, then that holds pretty well and it's repeatable. And then over here we have, in the unordered world of power law outcomes, we have the unknown unknowns. We have things that have maybe never happened before that can have a huge impact. And very importantly, in this quadrant, whatever's working today may not work tomorrow. The exact thing you think is working now may not work tomorrow. And these are generally what we call complex adaptive systems. So let's get into that a little bit more. Building a jumbo jet is complicated, but it's not complex. So I think of this as complicated here and complex over here. And so, for example, operating on someone's heart is pretty straightforward, and the people who do that almost always achieve their objective. But then running a hospital has a lot more unknowns to it, and it may still be, you can pretty well predict over the course of a year what your incidence of heart disease or how many operations you'll do, but you don't know for sure, and things can change over time. So you're trying to predict and trying to, again, build models in this quadrant. The problem comes when people try to model this area, because over here there's some success in modeling things like earthquakes, or modeling how a building works, or modeling how a project might go from beginning to end. But then as they play out, or as they interact with other systems, we find that something like earthquake damage does not model very well at all. Earthquake damage depends on tiny things that happen deep in the earth, and exactly where they are and how much they just randomly happen to be under valuable things that aren't very well supported, and so forth. So we can fairly well model earthquakes, even though we can't predict them. We could model them and have some idea, what to expect over the course of a year or 10 years or 100 years. But earthquake damage is impossible to predict ahead of time, because you just don't know where they will strike and how they will affect the structures. And in general here, I use the difference between soccer and the Tour de France, because in a soccer tournament, once you win a let's say the World Cup, once you win a round, then you start over on the next round, and everybody's equal, right? If you move on. And in the Tour de France, you carry every second with you, so the entire thing is additive, and that's called path dependence. So here in the unordered power law world, we have path dependence in all these areas. Parenting is a great example. Whatever you did, you can't undo and could affect a child or not, but it could, the child could remember that for many years or whatever happens, or, some accident. You got to play from there. It's like in golf, wherever you hit, you got to play from there. And then this is the area where we often apply models from here or here, thinking that they will work here. We think that the best practices, that what they do at Amazon will work for our company. What they do at Tesla will work for our company. I read something in the Harvard Business Review about how to manage people or hire people or reward people or whatever. And so we think that that's going to work. And that's just really mostly cherry picking and storytelling in reverse. And most of it is just nonsense and doesn't work. Getting an MBA is a good example, or in general, getting a college degree is a good example, because you don't know how that's going to play out. And that's 4 years of your life and a certain amount of money. And if you spend it and then, you do it and then you go through your career, we don't have the counterfactual to compare where you didn't use those 4 years studying and you didn't spend the money, but instead you went and got a job. And then, when you're, say, 40 years old later, we have no way to compare those two things. So however it turns out, people usually make up a story that's one thing causes another and that this is causal. And when you're in the unordered world, in a power distribution where it's mostly the unknown unknowns, that's where we can trip ourselves up by thinking we understand cause and effect. So here's a couple more examples. And the most important example I have here is ecosystems, because ecosystems are adaptive. So on the golf course, when you're hitting the golf ball, the golf course is not trying to kill you. The golf course doesn't care, right? If you're flying a parachute, the parachute is not trying to save your life. It simply doesn't care. It's just rope and fabric. Tend to work because as we build up experience, we learn what correlates with results. But pushing on one pedal here doesn't cause movement somewhere else necessarily. And there are many pedals. The economy is a good example. Most central bankers do not understand the economy very well, and they use outdated Keynesian models to try to adjust interest rates and so forth, and think that they're getting the economy just about right. And when the economy behaves the way they want, they think that they've done it, and they believe they're under control. That's called the illusion of control, because there are other times when they try the exact same thing and it doesn't really work because their models are no good. And so it's in adaptive systems that you have to watch out for black swans. A black swan is something that has never happened or may be very rare, like a viral outbreak, that can have tremendous consequences, where it may have a very small chance of happening, but if it does, it's the number one thing you want to think about. Right? If you live in San Francisco, earthquakes would be one of those things. You want to prepare not for an earthquake, but for the damage it might do to your property and property around you, or to the loss of life. So even a small earthquake in the right place can cause tremendously more damage than a big earthquake out in the farm country. So trying to look at things like cities or the human body or the universe are places where there are many conflicting theories. Experts tend not to work. You got lots of experts, so you can always cherry pick your expert to tell you what you think. And there are kind of a couple of different approaches to working in this area and trying to make predictions. One is called extreme value theory, that insurance companies use, and people who are actuarials are quite good at understanding very rare events that have big impacts. And so actuarials are good people to have on your team if you're in this kind of an area. And the other one is cost-benefit analysis. Rather than defaulting to something called the precautionary principle, where you say, well, something has a small chance, but it'd be very, very bad if it had, so we have to have zero chance of that. I don't believe that's the right tool. I think you want cost-benefit analysis really across the board wherever you see power laws. In general, you want cost-benefit analysis when you're looking at a difficult situation like, or a threat like global warming, or like AI supremacy, or rogue asteroids, things like that have a small chance of having very high impact. You want to use cost-benefit analysis, where you look both at not just the benefits of doing something, but the cost of what it costs you to do something. And that is a skill you can build. And if you're going to be working in this area, then I recommend, or really anywhere here, that you understand and build a toolkit of cost-benefit analysis. And so just to kind of put this in perspective, I say that in the ordered world, we have some things that work, although they have to be flexible. They shouldn't be too set in stone, because these things will evolve over time, but they generally work. And over in the unordered world, we're going to use different tools. And one of the most important tools we can use is experiments. Rather than having a theory and thinking that we know that global warming is going to be catastrophic, well, why don't we get some data and look at how that has played out? Why don't we look at the data? Why don't we build a model, make a prediction, and then do experiments, get data, and see if our model reflects anything about the real world at all? And if it doesn't, get rid of the model, get rid of the theory, and become much more empirical about the kinds of outcomes you can expect from your ideas. A good example for experiments would be to understand the effects of a minimum wage law. If you're thinking of passing a minimum wage law, you should look at where it's been done before, where it hasn't, where it has, and then they've changed it or repealed it. There are many examples where a law like a minimum wage law simply backfires and doesn't have the intended results. It doesn't help people. And in general, everybody adapts to the new reality, and real, actual wages don't change. That's why we have a serious recession every 10 years or so, because the models fail, and then people do the wrong thing, and that throws hundreds of millions of people out of work, just because a few people got the model wrong and weren't prepared for something very unusual. So I kind of sum this up by looking at ecosystems, and I have a bunch of, these aren't exactly rules, but these are characteristics of ecosystems. And I say that business is not like an ecosystem. Business is an ecosystem. In fact, business is a set of interconnected ecosystems, and they are all complex adaptive systems that interconnect in ways that we can't possibly understand or predict and can't model. That's why hedge funds fail, because their models don't understand complex adaptive systems, and plenty of them do. So let me just read you this list. So we have hundreds of simultaneous arms races, many of which are invisible. We have auctions all the time in which people make irrational emotional choices and just try to win rather than get the best deal. Beauty contests all the time, and often with winner-take-all economics, especially in startups and in technology companies and platforms. We have moving and even impossible to find targets. We think we know what the targets are, but not only are they moving, sometimes we're just going after the wrong ones. That's very common. I have a new essay on that just came out this week on shortfalls. There are black swan events that simply haven't happened before, but when they do happen, or are very rare, and when they do happen, they have tremendous impact. There are implicit games with unwritten rules, and this is true everywhere, not just in personal relationships or families, but also in organizations and institutions and laws and in society. Then we have people gaming the system at all times. That's an example of that is the media. Everybody in the media business is always gaming the system, and everybody pretty much everywhere is always gaming the system. So getting the rules, so improving the rules is a good way to improve the system rather than go after the people gaming it. And this goes for setting laws and regulations as well. And remember, it's complex adaptive, so others are pre-gaming and regaming and overgaming and undergaming the system all the time. It's hard to know what stage you're in. There's tons and tons of data, which means there's lots of noise. There's mostly noise. So we say that for every PhD, there's an equal but opposite PhD. And we know, actually, through very good research by John Ioannidis, that the vast majority of all published peer-reviewed papers are just wrong. So no shortage of data, that doesn't really mean much. Solutions that are temporary and can easily be eclipsed by new, as we go to the next generation. And then we have adversaries and allies, some of whom are exactly the same people or change and become the same people, and are often morphing into and out of each other. And sometimes we are unaware because there's so many. If you look at the org chart of a company, you can't see the adversaries and allies, and you can't see underlying who's talking with, playing with, scheming with, or uncooperating with whom. And that's where that's the important stuff. We have the fast rise of new frontiers. So if you probably noticed that very little happens in a single year, but over 10 years, it's amazing how much happens over 10 years. It's like 100 times more happens in 10 years than it happens in 1 year. And that's because of the power law. And then we have sudden death in companies that you sort of thought were solid, or people or organizations that you thought were solid are suddenly gone. And you have the Red Queen effect, which is living in the VUCA world. It's just another module I have, where it's always an arms race, and you're always trying to go, as soon as you achieve something and you're ahead of the game or you have an edge, everybody else catches up, and then you start again and there's a new normal. So that's just one quick module from the Agile worldview, ordered versus unordered. I have about 15 of them here. And then I have about, 10 other whole groups of modules. This is several days of workshops, but I hope you enjoyed it. This is David Siegel for Business Agility Workshop and Cutting Through the Noise. See you next time.